let's talk about graphing an absolute value equation like this. First thing that would be helpful is to know this vertex form for a normal absolute value function, where A has something to do with the width of the absolute value equation, and then the HK value is the vertex. So this is vertex form for a absolute value function. So the A value determines the direction, whether or not it's opening upward or downward, and it also determines the width. All absolute value functions like this are V-shaped. So it's either a V that's opening upward or a V that's opening downward. Well, one way to graph this is just to make a really big chart of X and Y values, substitute a bunch of things in here for X, solve for Y, and plot them. That will work, but you might not find the vertex that easily. Second way to do it is to know this form really well and to transform this into that form. So notice if I take this, I need to have an X there, so I'm going to factor out a 3. So if I factor out a 3 from this, I have a 3 on the outside. 3 times X is 3X, and 3 times negative 1/3 is negative 1. So I've transformed this to this form, which makes that a 6. And it looks like this. And so my vertex is 1/3 and negative 3. 1/3 from here and negative 3 from there. So if I plot that, I get here, and my axis of symmetry goes right down the middle at 1/3. So the axis of symmetry is this imaginary line, X equals 1/3. And then I do a table. I pick one value to the right of this vertex, which I picked 1 1/3 and plugged that in and calculated it and got 3. Here's how I did that. 1 1/3. 1 1/3 minus 1/3 is 1. The absolute value of 1 is 1, and 1 times 6 is 6, and 6 minus 3 is 3. And then I use negative 2/3. Well, negative 2/3 minus 1/3 is negative 1. The absolute value of negative 1 is 1, and 1 times 6 is 6, and 6 minus 3 is 3. So I picked these strategically because of that 1/3, and I got these two values. So what I did was I plotted those. So I have 1 1/3 and 3, and then I have negative 2/3 and 3. So that's where those 2 points came from. So here's my vertex. It's a V that's opening that way with this axis of symmetry. So that is a second way to graph this, and I think it's a more effective way because you really only need 3 points. You need the vertex, and then you need 2 points in your table. Now, you don't have to pick, if you're not great with fractions, you don't have to pick those. I picked those because I am pretty good with fractions, and I wanted to make my calculations pretty easy. But you could have just as well used whole numbers. So you could have picked a 2 here, and then you could have picked a negative 1, and hopefully you would have been able to calculate that and get numbers, and your graph would look the same way. Okay, so the third way, and probably the way that's in most textbooks, is to take this, and instead of factoring out the 3 like I did, what you do is just take this part that's on the inside, 3x minus 1, set it equal to 0, move the 1 over and solve for x, you get x equals 1/3. So your vertex is going to be 1/3 because of what you got here, and then your y value on your vertex is going to be negative 3. So you can get this 1/3 without factoring it like this, but by just setting this inner part of the absolute value equal to 0 and solving for x. And so you might find that to be a little bit better way. But once you get your vertex like this, you can do your table from your equation here, from this equation even. So once you have your vertex, you can use that equation to do your table. And then you don't have a fraction, so it'll be easy to calculate with 2 or negative 1 or whatever you want to. So give that a try and see if you don't get the same graph either way. So that's about 3 different ways to do it. So you can just make a big old table of values and plot a bunch of points until you find the shape of the V. Use a variety of positive and negative values and use 0. Plug them in there. Fire away. Do a table of about 10 or 11 X and Y ordered pairs and plot them. That's one method. I don't recommend that, but it will work. Second method is to factor this out so that you have it looking like that and use your vertex and do your table. The third way I think is probably the best way, and that is to take this and set it equal to 0 and solve for x. And that gives you the x value on your vertex. This is going to be the y value on your vertex, so you're still going to have the same vertex. And then use this equation to do your table of values and pick one point to the right of the vertex, one point to the left of the vertex, and then draw your graph. Usually when you do the graph, you're labeling the vertex, you're labeling the axis of symmetry, and of course you have a couple of points and you show your table and all of that. And it's just that your vertex is in a new place. If somebody asks you something about how this compares with the normal absolute value function, it has a vertical stretch by a factor of 2 because this is out here. It's opening upward because this is positive, and the vertex is moved over 1/3 to the right and down 3 because of that. So you can answer some questions like that as well. So they may ask you some questions about shifts and stretches and all that good stuff. Anyway, hope that helps with graphing an absolute value function.